Okay, so in this we're going to cover partial fraction decomposition and how to use it and how to do it. And it's pretty straightforward, but it does take a little bit of finesse. So let's just say we have a random polynomial, ax squared plus bx plus c, and this is all over x times a factored form of another polynomial. So instead of using a's and b's, I'm going to just go with the higher letters in the alphabet. So y and z will just be numbers. And we're going to break this down into a over x plus b over x minus y plus c over x minus z. So what we've done is we've taken the numerator and we've broken it down into three separate fractions here. It doesn't have to be three, it just happens that the denominator is factored into three pieces. So that's the sort of key here. Now, uh, we'll just do an example because that will essentially work through the nuances. But we want the numerator and the coefficients to equal the coefficients of this. So let's say we have 2x squared minus 2x plus 4. And this is going to be over x bracket x minus 3x plus 4. And I want this to now equal a over x plus b over x minus 3 plus c over x plus 4. So I've broken the denominator out, and now what I'm going to do is essentially multiply by the LCD, the entire thing, every term on both sides. So the LCD is this. So when I distribute it and I hit every single term, so if we hit this one, and this one, and that one, and then that one, the denominator disappears here, but here I'm left with an x minus 3 and an x plus 4. Here I'm left with an x and an x plus 4, and here I'm left with an x and an x minus 3. So what we end up with is 2x squared minus 2x plus 4. The denominator canceled out, and now I have a times x minus 3, x plus 4, plus b times x, x minus 3, plus c times x, x minus 4. Oh my god, this is plus 4, and this is minus 3. So let's rewrite that because the marker's hard to see. X plus 4. Okay, so now we're going to distribute this, and then we'll see what we get. Now we have 2x squared minus 2x plus 4 equals, and I'm going to leave the a out. So we have, this is x squared plus x minus 12 plus b, and we distribute this, which is x squared plus 4x, sorry about messing that up, plus c, and this is going to be x squared minus 3x. And now I know that the coefficient in front of the x squared has to equal the coefficients in front of these. So that tells me that 2 must equal, and I have in this term an a, and in this term I have plus b, and in this term I have a plus c. Okay, that was kind of handy. Now I have negative 2 for the x term. Here I only have an a. In this one I have plus 4b. And in this one I have minus 3c. Nice. And now in this last one for the constant we have 4. And that's equal to minus 12a. And there's no constant here and no constant here. So we know that that tells us a must equal negative 1/3. Perfect. We found our first value here. But we still have to find b and c. So to do that, what we have to do is go back to our other two equations, and we're going to essentially use a method of elimination to eliminate the c, or we could eliminate the b and find the value for the other unknown. So let's call this equation 1 and this equation 2. So now I'm going to take I can see that if I just multiply equation 1 by 3 and add it to this, the c's disappear. So I'm going to take equation 2 and I'm going to add 3 times equation 1. So if I do that, I have minus 2 equals a plus 4b minus 3c. Now I'm going to add 3 times this one. So that's 6 equals 3a plus 3b plus 3c. And when we add those, I get 4 equals 4a plus 7b. Nice. Okay, so we're going to go to another page because we're running out of room here. And so now I've got this equation and I have a. So I'm going to go through and solve this. So I have 4 equals 4 times negative 1/3 plus 7b. So now I'm going to solve for b. So that tells me b is 4 plus 4/3, which is 16/3. But I had the 7, so I'm going to multiply that by 1 over 7. So I get 16 over 21. So that's pretty handy. Now what I'm going to do is I want to find c. I'm just going to take a and b and solve for c. So now the last equation, the last unknown, is 2 equals minus 1/3 plus 16 over 21 plus c. And if I multiply this by 7, top and bottom, that's the same denominator. So that's 2 equals 7 over 21, negative 7 over 21 is 9 over 21 plus c. So that's c equals, if I reduce this, that's 3 over 7, and that's 14 over 7. So minus 3 over 7 equals 11 over 7. So that is the final constants. Now I've got a equals minus 1/3, b equals 16 over 21, and c equals 11 over 7. I can now go through and solve this, and I'll just say 2x squared minus 2x. Let's move this up. Sorry. Plus 4 is x bracket x minus 3 x plus 4 decomposes into a, which is minus 1/3 over x, plus 16 over 21 over x minus 3, plus 11. Sorry, I just want to make sure it was a positive, over x plus 4. And that is our partial fraction decomposition. So if you were to integrate, if you were integrating and you were given this, you could just use partial fraction decomposition to turn into 3 separate terms. And this is much easier to integrate. This is just the ln of x, right? So you have this constant that you can pull outside the integration, and you just get, like the integral of negative 1/3 over x dx is then just negative 1/3 ln x plus some constant.